Hello and welcome to another video. I'm Adam, and today we will talk about the lift equation, basically basics of the lift equation. We're not aerodynamicists, so we're going to talk basics. Keep it simple, short and sweet. So here we go. Lift equation. Lift equals coefficient of lift times the surface area times half rho times velocity squared. So how do each of these impact lift? Coefficient of lift is much to do with the airfoil design, and it is basically a measure of an airfoil's ability to produce lift. Associated with that, and where we can affect coefficient of lift, is with angle of attack. If we increase angle of incidence on a rotor blade or increase the angle of attack of a wing, then we are increasing lift produced. Surface area, the surface area of the airfoil, how much is available to produce lift. For helicopters, there are some aerodynamic factors that impact this, can decrease the surface area. We're not going to cover that in this video, but we will cover that in later lessons where we discuss particular tasks and aerodynamic phenomena. Next, we have air density, self-explanatory. How dense is the air? More dense air, more lift produced for a constant velocity and angle of attack, and less dense air, less lift produced. Pretty straightforward. Temperature and humidity have an impact on air density. We need to be aware of it because if we're operating in an environment with less dense air, then obviously performance is impacted, and reduced performance is going to be available to us. Velocity squared, notice it's exponential. So if you double your velocity, because it's squared, you quadruple the lift produced. So velocity is a major factor when it comes to producing lift. And this is the airflow over the airfoil here. For a helicopter, we have blades that turn. So the blades in a stationary hover, those rotor blades, that rotor RPM, can be represented by this velocity. You increase the rotor RPM, we increase lift produced. We reduce rotor RPM, lift is reduced. And you can see that. Stationary hover, increase, decrease throttle if you have the ability to do so. Those are the basics of the lift equation. Told you it was going to be simple. Angle of attack, increase it, lift increases. Decrease the angle of attack, lift decreases. Doing this with angle of incidence with the collective. We already discussed air density, discussed surface area. We really can't change these. Velocity, rotor RPM, you increase it, you increase lift. Velocity decreases, lift decreases. That's basically it. As I said, we will refer to this more as we produce more of these lessons, and so this will be a good reference for you to go back to as we teach more tasks. Okay, let me know if you have any questions, put them in the comments, and don't forget to subscribe, like, whatever you want, and I hope you enjoyed the video. Take care, God bless. Bye-bye.